So number 4 is similar to number 3. We're going to rewrite the following expression so it contains at most one radical term that does not contain any perfect square factors. Assume the variable is non-negative. So step 1 is always get everything into prime numbers. So I'm going to find factors of 32. Okay, so again, if you're not sure about your times tables, just use a calculator. But 4 times 8 is equal to 32. Neither of these are prime because they break down into more factors. So I'm going to break down 4, which is 2 times 2, and 2 is prime, so I'm going to stop. And then 8 is 2 times 4, and 2 is prime, but 4 is 2 times 2. So all of these prime numbers are equal to 32. So step 1, I have 5 2's. 2 times 2 times 2 times 2 times 2. That's 32. I just rewrote it. And then there's going to be 15 A's. So I would 1, 2, 3, 4, 5, 6, 7, and I could keep going until there's 15. So step 2 is to find the pairs because my index number's 2. Remember, when there's nothing there, it's 2. And that tells me my grouping. So I'm going to find groups of 2, and that comes out of the radical. It's just 1, 2. Find a group of 2. It comes out as just 1, 2. And then there's going to be this 2 left over because it doesn't have a pair to come out with. And then there'll be pairs of A's. It's like there's a pair, there's a pair, there's a pair. And remember, we did that trick. We did 15 divided by 2 because that's our index. And that's going to give us a decimal, 7.5. But that means that I'm going to have 7 A's that come out. So 7 pairs. 4, 5, 6, 7. And then this half tells me that there's going to be 1 A left over. So outside the radical, I have a 2 and a 2 and 7 A's. 4, 5, 6, 7. And inside the radical, I have a 2 and an A that did not have a group, so they were left inside. So step 4 and 5 tells me to multiply all these. So 2 times 2 is 4, and then 7 A's, we would write A to the 7th power. And then inside the radical, 2 times A, we just write as 2A. And that would be our answer.